Okay, so just try to do some basic problem, and they are from your net examination. So I have deliberately selected this problem because these have some different type of concept, as well as they are in the trend of examination. So you have to always focus the trend. Obviously, you have to just work for each and every problem. That is very important. But yes, hence we are preparing for the competitive examination, then we should follow the trend. So trend is very important. So let's go for one problem. This is my one of the very favorite question, and let's try to this one. And this question was come in exam, I think December 2014. So at one time there was a suddenly the level of examination was changed, and we just go into the different plateau. As in the last paper also we go into the different plateau. So we have to be prepared for really very nice questions. Okay, so let's go for question. What is question? And I am not giving you the four option. Okay, I don't believe in these four options. We have to solve it completely and give the answer. And yes, whatever be the answer ABCD, you can just stick with yourself. But we are just going to solve it completely. Okay. So this question is that there is a classical Hamiltonian, and this classical Hamiltonian is omega xp, where x is position and p is momentum. So these things are given, and it is also given that x is position operator. So x will operate on some psi x. We have x psi x, and p will operate on some psi x. This is equivalent to minus I h cut del psi upon del x. So what we have to do, we have to just figure it out. What will be the, and this is classical Hamiltonian, please. This is classical Hamiltonian, and we have to write this classical Hamiltonian in term of quantum mechanical Hamiltonian, in term of operators. So this is very interesting. Now, in general, people have done some blunder into exam. What they done? They just write their Hamiltonian something like this. They just write their Hamiltonian omega x into p. Okay. But this cannot be Hamiltonian. Why? Because this is not a Hermitian operator. Because x and p is not going to commute. So what you have, suppose I am just going to find H Dagger, then this will be, let's say omega is some positive constant, some real number. So there is not any problem. But we have x and p, and when we are taking a dagger form, then obviously this will be p dagger, x dagger, and obviously these are Hermitian, so this will be p and x. But the most important part is that this xp is not equal to px. So this is a real problem. So you cannot write this thing equivalent to this one, or you cannot write directly x here and p here, because this Hamiltonian is itself not a Hermitian in nature. So you have to be very much careful when you are talking about the physical quantity, when you are talking about the observables. Observables are those quantity which can be physically measured, and the operator associated to that observable must be Hermitian in nature. This is very important. So what we have to do?
Plus px by 2, right?
Yes. I am just explaining you. If you maybe you have done this thing, so let me explain to me. Whenever we need conversation, we will discuss it. Okay.
Yes.
So what we have to do? Then we have to play a trick. So whenever you have this type of problem, just check whether it is Hermitian or not. If it is Hermitian, then obviously you can straightforward go for this. But yes, if this is Hermitian and you can go for a straightforward, why they will give you into the examination? They will never give you in the examination. Obviously, there should be some trick. So what we will do, classically we have x and p is equal to p and x. This thing can be written in the classical mechanics, and this is my classical Hamiltonian. So what we can do, we can rewrite this classical Hamiltonian as omega xp plus px by 2. We can easily rewrite this particular Hamiltonian, isn't it? This thing and this thing is same thing in a classical mechanics. But what is beautiful part of this thing? The beautiful part of this thing, that this particular term is Hermitian in nature. Look at the beauty of this particular writing my classical Hamiltonian in this way. Because if you are just going to check it, what will happen, H dagger, then this will be omega upon t. This is real. We have xp whole dagger plus px whole dagger, and now you can have this particular thing omega upon t px plus xp. Now these two are same thing, so we have h is equal to h dagger. So yes, I can rearrange my classical Hamiltonian in such a way so that we can write this thing as a Hermitian operator. So first thing is that whenever this type of problem will give in your exam, try to make it Hermitian if it is not Hermitian. And yes, the best way to write this thing, that you can write another operator first, another second one, and you can divide in by the 2. Okay, we will do such type of operator again into angular momentum and all places. Okay, so now this is my now I can write this thing as a my quantum mechanical operator. So what we will do, we will just operate some psi x, isn't it? This is the way that you can write the equivalent operator. So what will happen? So you can write omega upon 2, and I will write this is xp plus px psi. And here we can just go for omega upon 2 xp psi plus px psi. So what will happen when p will be operate on psi? We have omega upon 2, x will be just like this, p will operate when psi. We have this definition. So we have minus ih cut del psi upon del x plus p, and this thing is x psi, isn't it? X will operate on psi, we will have x psi. This x is variable, this is operator, so you have to always keep the thing, you have to always be crystal clear about this particular notation. Okay, now what will happen, now this x will operate on this, what you will get, you will get omega upon 2 and minus ih cut I can take here. So this will be x del psi upon del x, and here we have minus ih cut del upon del x, and this is just going to operate on x psi x. You remember we have done this thing when we have done as a commutator, है ना, किया था ऐसा?
Yes, sir.
So we can just take minus I h cut upon omega, sorry, h cut upon 2 omega, and we have x del psi upon del x plus, we have to first differentiate with x, we have to take psi x, something like the differentiate. So x, we will differentiate to x, then we will get psi x, and then we will just keep x here, we will differentiate it, then del psi upon del x. So this thing is something like this, minus h cut omega upon 2, and we have 2x del psi upon del x plus psi x. We can take psi x and we can just compare these two things. So here we have to compare this thing. So what will happen? We have this h psi x is equal to minus ih cut omega upon 2 x del upon del x plus 1 and identity psi x. And if you want, and this is 2 here, sorry, this is 2 here. So if you want, you can take inside this 2. So this will be minus IH cat omega, and we have x del psi upon del x plus half into I. This is h psi x. Now this h will be equivalent to this one. Okay, and this will be your answer. So yes, step by step, I deliberately taking this class because some students have feeling that when they will go into exam, they have to just tick the option. Forget this concept, forget this thing. If you are have this type of mindset, leave the exam. You are not going to select it. You have to solve each and every point step by step. Sometime you can just do fast calculation, sometime you can use the formula, but yes, concept wise you have to do each and everything concept by concept. Now if you have any doubt into this problem, you can ask me. Otherwise I will go for one of the my next favorite question. Okay.
Sir,
Hmm.
sir, XP is not equals to PX, right? That is why this H
Yes,
equals.
yes, exactly, exactly.
Then, sir, H equals to omega by 2 XP plus PX equals to
Yes, you can take
omega
the
XP.
you
How?
can take this thing, you can take the Hermitianity and you will get the exactly same thing. I have
Sir,
proved this
this
thing.
I am.
I have proved
Sir,
this thing, na?
yes, sir. This I am understanding, sir.
So what will happen?
So, I am not able to understand that how omega by 2 XP plus PX equals to H equals to omega XP.
This is equal to this.
Second step, yes,
These two things are same
yes,
thing in the classical mechanics. Doesn't this thing is same
okay,
thing in
sir.
the into the classical mechanics?
Yes, sir.
You can write 2 is equal to 1 plus 1. Is that any fault
Yes,
into this?
no, sir.
So I am writing it I am writing it classically. So there is not any harm to writing it in classically. Okay.
Oh, okay, sir. Sir.
This is not, I am right. I am transforming my classical Hamiltonian like this. Are you getting my point? And here is the all
Yes, sir.
catch. Here is the all catch. And these two are same thing, isn't it?
Yes, sir.
Because
Then they are.
because order is not important into classical mechanics.
Yes, sir. Classical not order is not.
Yes. So first I changed my classical operator, and then I use this particular quantum mechanical operator. Are you
Yes,
getting my
sir.
point?
Well, we could just use the commutator, right? XP minus PX is IHR.
What you are doing? Are you comfortable with this thing or not?
Yes, sir. Yes, sir. No,
Then
I'm
it's
not. I'm
okay.
just asking that.
No, that's it. That's over. Listen, when you are solving the problem, just stick to the concept. Okay? Just stick to the concept, because time is also very important. And you can do it in another way also. If you are getting it, if you are getting the answer into another way, you are always welcome. Okay? So you have another method also. But your answer should be just like this. Okay? This is most important thing.
Yeah, it's one liner basically. PX is XP minus IHR, right?
Whatever the thing you are asking, just send me on your group. I will check it. Okay?
Okay, sir. Okay.
Now, let's go for one very nice problem. And this is all about the commutation. So the commutation problem is always interesting. So let's try to go for first 3 different problem on the commutation. So we have 2 operator. So, and I think this problem was in 2012. So this is again a very old problem. So, and June 2012. Okay. June 2012. Okay. And we have operator A and B operator, and this operator is equivalent to identity. it is given that commutation between these two operators is identity. Then what we have to do? We have to check which one is the correct one. So I just make it in this form. So we have to calculate basically e to the power a, the commutation between e to the power a and b. So this type of question is very famous into your exam. You will always find this type of problem will come, that you have function of operators. Here it is given e to the power a. Sometimes they will give you sine a, sometimes they will give you cos a, and this type of function will be always there. So this kind of problem we have to solve. So what is the value of e to the power a and b? So obviously we have to use this condition. We have to use this condition and we can easily figure it out. What will be the value of e to the power a and b? So in this type of thing, what you have to do? Hence, we know the relationship between a and b. Then obviously what we have to do? We have to first do the Taylor expansion of e to the power a. And then we have different relationship between the commutations. So let's try to go for it. What will happen? So what will be e to the power a? This will be 1 plus a plus what will happen? A square factorial 2 plus we have a cube factorial 3, and similarly you can go for b. And now you have n number of commutation, isn't it? We have n number of commutation. So what will be first commutation? The identity
Sir,
and b. Yes.
sir, shouldn't the first I in the
Sorry?
Taylor series expansion?
Sorry.
Sir, the Taylor series expansion we have
That is I. That is I
first
actually. If I am writing it 1, that means it is I. Okay, in a matrix form.
Yes.
Okay.
Sir,
I
this
into
is valid.
Huh?
Sir, I may be wrong. I have one doubt. This expansion is valid when A is a diagonal matrix, na? At that time, only we can. Or it is general case.
No. A is not diagonal matrix. This is valid when A is diagonalizable.
Okay.
Okay. These two things are different. Whenever A is diagonalized, it can be diagonalized, then you can use this thing. If it is not diagonalized, then obviously it is problematic. But yes, A and B are operators, so we can assume that they are diagonalized. Okay, they are operator associated with something, with some physical quantity, then obviously they will diagonalized. Okay, and on the basis of some matrix, on some vector. Okay.
Okay, sir.
Okay. Now, what will be second one? Second one is A and B. And what will be third one? We have A square B by factorial 2. And similarly, you can go for all other thing. So what will be first commutator?
0.
That will be 0. What will be A and B? I. And what will happen to this one? 2 times A, isn't it? You can just take A into A and B, then that is 2 times A into I. I will be just work like this, isn't it? What will be next one? Can anybody tell me? That will be 3 by factorial 3 A square, isn't it? So this type of recurrence relation will be, this type of relation or this type of series will be there. So what will be ultimately you will get? I plus A plus this 3 and 3 will cancel. You have again A factorial by 2 plus you have next term you can check, that will be A cube by factorial 3, and that value is equal to nothing but e to the power A. So if this will hold, we can easily prove that this value is equal to nothing but e to the power A. Okay. So I deliberately taken this one because next problem will be just similar to this one, and you can do it with yourself, but I will also give you some shortcut method or some different approach to do this particular thing. Okay, when it will be written in a position and momentum. Yes, anything else?
Sir, वो A square by 2 factorial है ना? a square by 2 factorial a cube by 3.
हाँ ये तो
Second
कर लिया
statement.
ना, यहाँ तो कर लिया, ये किया तो ये आ गया.
हाँ सर, लेकिन लास्ट स्टेटमेंट का क्या
Oh, this one is for this, next one is for this. Are you
Okay.
getting my point?
Yes, yes, sorry.
So this 2 and 2 will cancel, this 3 and 3 will cancel. Okay.
Okay, sir.
So just try to do each and every step by step thing. Okay. So this is one particular problem. And this is very interesting one. Why this is interesting one? Because if you want to, suppose I will just give you sine A, B, then again you can do this kind of thing. And you will see whenever this type of problem will be there, then you have some series coming related to this function. Either you have series related to that function only, or you can have series related to its differentiation or its first order differentiation or something else. So always you have to keep in mind that when you will open all this commutation, you will get some particular series. Okay. So this thing you have to always keep in your mind. Okay. Now next two problem, look at how next two problem is just related to this one. So let's go for next problem. इसमें कुछ पूछना है? Everyone is comfortable?
Yes, sir.
Yes,
Yes, sir.
Okay.
Yes, sir.
Now, the next problem is we have to find, and this problem was asked into some in exam. I will just give you the time of exam also. So this is in December 2014. So the same trend is there. Now look at what is this problem. We have to figure out what will be x p e to the power minus p. What will be commutation between x p e to the power minus p? We have to just figure out this thing. And in this particular problem, they have taken h cat is equal to 1. So there is not any problem. H cat is equal to 1. We can put it easily.
तो सर
Okay.
सर क्लासिकली दे सकते हैं इसको?
क्लासिकली भी देख लेंगे, बट पहले मैं क्वांटम मैकेनिकली करूंगा, और आप चेक
Okay.
करके क्लासिकली भी देख सकते हैं. ठीक है. सो देयर इज नॉट एनी प्रॉब्लम. ठीक है, आप बिल्कुल सही बोल रहे हो. ये हम लोगों ने एक क्लास में डिस्कस भी किया था दैट देयर इज रिलेशनशिप बिटवीन पॉइजो ब्रैकेट एंड बेसिकली द कम्यूटेशन यूज्ड इनटू द क्वांटम मैकेनिक्स. बट वहां पर दोनों आपके पोजीशन और मोमेंटम के ही फंक्शन होंगे, तभी ऐसा कर पाओगे, है ना.
Yes,
जैसे
sir.
लास्ट प्रॉब्लम में ए और बी था, वहां पर आप ऐसा नहीं कर सकते, इजंट इट?
Yes, yes.
बिकॉज यू डोंट नो व्हाट
अब
विल
यहाँ
बी,
पे
है ना. जहां पर एक्स और पी होगा वहां आप ऐसा कर सकते हो. दैट इज डिफरेंट इशू. बट हमें सीखना है कि हम क्वांटम मैकेनिकली कैसे करते हैं. दैट इज वन वेरी गुड रिजल्ट यू कैन यूज ऑलवेज. सो उसको भी करेंगे, डोंट वरी. सो दिस थिंग इज देयर एंड वी हैव बेसिकली एक्स एंड पी इज इक्वल टू आई. ओके, एक्स एंड पी इज इक्वल टू आई. So how you will go for this particular thing? Obviously, we have x operator, we will take p operator, and then we will take the Taylor expansion of this one, isn't it? Or you can just take something first. We will just write something this xp, and we have e to the power minus p plus p x e to the power minus p commutation, isn't it? So first thing is there, what is x into p? That
I.
value is I into h cut, but they have told you that take the h cut value is equal to 1. So I e to the power minus p plus. Now here again you have to go for Taylor expansion, isn't it? There is no other way. You have to go for Taylor expansion. Then what will happen? X again I. What will be second term? Minus p.
minus p
What will be third term? Plus ना?
plus
मुझे
Plus
देखो
plus
फॉर्मूला
plus
याद नहीं
plus
रहता है. फॉर्मूला आपको बताना पड़ेगा. What will be third one?
minus
Minus p cube by 3 and so on. Okay. And now we can use this particular thing. So I e to the power minus p plus, we can take p here, then this will be, and we have big bracket x and I minus x and p, and then 1 upon factorial 2 x and p square, and then minus sign, you can have something like this. What will be x and I e to the power minus I p plus, what will be x and I?
0.
0, because identity operator किसी के साथ भी commute करेगा. What will be x and p? I. What will be xp square?
2x
2 times IP
2 times ip by factorial 2, isn't it? What will be next one? बताओ next one क्या होगा? Plus or minus?
3i
Minus sign ना? So that will be what? 3i p square by factorial 3 and so on. Okay, so this is our way to open all this thing. So this will be I e to the power minus ip plus p, then first term is equal to minus I. So I can take minus I common, ले सकते ना? And then we have identity, and what will be this one? Minus p. What will be next one? Plus p square by factorial 2, and then we can go for higher order term. So obviously, what will be this value? So this value is equal to I e to the power ip plus p, and here we have minus I, and what is this value? This value is equal to e to the power minus p, isn't it?
सर पहले
e
वाला
की पावर माइनस IP कैसे हुआ सर? पहला टर्म माइनस p चल रहा है सर.
minus p, that was mistake.
Minus p. Wait, sorry, I कहाँ से
नहीं,
लिया
first
मैं?
term, yeah.
Oh, sorry. I कहाँ से आ गया? ठीक है, okay, thank you. So this I sign will be not there. वो गलती से आ गया है ना?
And
So मेरा
minus will be there.
हाँ?
Minus p. It will be minus p in the first term.
obviously minus p. Actually मेरा focus सारा यहाँ है, ठीक है? So okay, so this will be your answer, and now you can easily write this thing. So what you can take common? You can take I e to the power p common, and that value is equal to 1 minus p. Okay. Now
It will be
just
minus p common.
e to the power minus p, obviously minus p is common. Thank you. So yes, this will be. Now just try to figure it out. What will be the Poisson bracket of this one? Just try to figure it out. What will be Poisson bracket of this one? We have to just go for del x upon del x, del p, or del x upon del x, del p e to the power minus p upon del p minus del x upon del p into del p e to the power minus p upon del x. Just I am using the classical thing. So what will happen? This term is 0. Yes. And what will be this value? This value is 1. And what will be this value? This value is, first you have to differentiate p, then e to the power minus p, and then you have to take plus 1 and p minus 1 e to the power minus p, isn't it? So this is e to the power minus p, 1 minus p. Yes. So look at this thing.
Yes, sir.
This thing is exactly same to this one. Are you getting this one? These two things is exactly same to this one. And what will be relationship between classical and the quantum mechanical commutation? That quantum mechanical commutation is equal to classical commutation into I into h cut, if we want to use the quantum mechanical commutation. And we have already seen that there is a relationship between Poisson bracket as well as commutation into the quantum mechanics. So here h cut is equal to 1. So you have exactly same answer. Yes?
Yes, sir.
Okay. Now,
Yes, sir.
last last to last year, I think this was the next problem was very interesting, and let's try to solve this one. And this problem in the booklet is not correctly solved, so you can just check it, okay, and you can just correct it. So next problem जो मैं कर रहा हूँ, okay, so let's try to go for the next one. करें क्या? And that will also depend on commutation, okay.
Yes, sir. सर
हम्म
सर बुकलेट में फर्स्ट चैप्टर का जो सॉल्यूशन है वो सर गलत है,
किसका?
मतलब फर्स्ट चैप्टर का सर, ऑपरेटर टूल्स टूल्स का।
हाँ, कुछ जगह में स्पेंडिंग होगी, वो मैं ठीक करवा दूंगा आपको, है ना, वो आपके पास आ जाएगा, डोंट वरी, वो मैंने ठीक कर लिया है, कुछ जगह में स्पेंडिंग है, उसे ठीक कर लेंगे, ठीक है।
यस सर।
So now look at next problem. It's a very interesting one. So what we have, let me tell you the problem. This is very interesting. And this problem was, just wait. Yes. So it is given that X and P is equal to I H cut. So this is given that X and P is I H cut. If X kit is the eigenstate of X operator, okay. So X kit is the eigenstate of X operator with eigenvalue X, okay. So this is given, this is your eigenvalue X kit. Now question is that what will be eigenvalue to the, just a minute here. So what will be eigenvalue associated to the function e to the power I a p upon h cut x kit? What will be eigenvalue as what when x will operate on this one? What will be the eigenvalue? Are you getting my point? क्या इस प्रॉब्लम में पूछ रहा है? When you will operate x on this particular function, what will be eigenvalue? So we have to see how we can approach this particular problem. Okay. So now we have xp is equal to ih cut. Let us try to figure it out. What will be the relationship between commutation e to the power I a p upon h cut? Okay. And now if we are just finding this particular commutation, so we can find it either with the help of Taylor expansion or by using the Poisson bracket, and we can multiply it by ih cut, because xp is nothing but what? Ih cut. So just I am using the shortcut method to find this particular commutation x and e to the power I p upon h cut. So let's try to figure it out what will happen. So obviously what will happen? Del x upon del x into del e to the power I a p upon h cut upon del p minus del x upon del p into del e to the power I a p upon h cut x. Okay. So what will be this value? Just tell me. This value is I a h cut, isn't it?
Yes,
E to the power I a p upon h cut. That is the value we can easily find, and but we have to multiply it with what? I into h cut for this particular commutation, and for the quantum mechanical
sir.
commutation,
Yes, sir.
we have to multiply with I h cut. So what will happen? So this value is minus a e to the power I p upon h cut, isn't it? Now let us try to open this one. So what will happen? we have x e to the power I p upon h cut minus e to the power I a p upon h cut into x, and we have to operate x kit on both sides. So this will be minus a e to the power I a p upon h cut x kit, and here this thing is x e to the power I a p upon h cut x kit, and this thing is just x will operate on this one. So what will happen? E to the power I a p x x kit minus a e to the power I a p x cut, and what will be value? X minus a e to the power I a p upon h cut x kit. So look at, this is your eigenvalue, isn't it? This is your eigenvalue if this is my eigenvector, isn't it? X will operate on this operator. What you will get? You will get x minus a, and if this is your eigenfunction. So this is one of the very wonderful problem. Okay.
Yes, sir.
Anna, and this was into the last year exam. Okay, last to last year, I think so. Okay, so let's go for one more problem that was asked into last year exam. Okay, and this is wonderful problem. I have already solved it in a separate video, but I will solve for you into the class. So let's go for last year problem. This is a wonderful problem. Are you people comfortable up to this?
सर ये जो ऑपरेटर मतलब कि जो ये वेव फंक्शन है तो x माइनस ए हो जाएगा सर फिर तो.
This is your eigenvalue and this is your wave function. क्वेश्चन क्या पूछ रहा है? ये अगर वेव फंक्शन है और x ऑपरेट करोगे तो क्या आइगन वैल्यू होगी अगर ये दिया हुआ है तो?
आइगन वैल्यू. ठीक है सर, ठीक है.
ठीक है, so this is your eigen value. X will operate on this one. Look at, you have something like eigen value equation ना?
यस सर. तो सर मतलब कि जो अगर ये ऑपरेट करेगा x पे तो कहते हैं x माइनस a का फंक्शन आ जाएगा ना वेव फंक्शन.
इसके ऊपर ऑपरेट करेगा तो इन पूरे फंक्शन पर इसे आप साई x कर सकते हो. ठीक है, इसके ऊपर ऑपरेट करेगा तो ये मिलेगा. ठीक है,
ओके
ओके, गुड. Now this is in the last year paper, just in whatever the exam happened into this time. So that is in June 2021. So they just give you Hamiltonian. And what is your Hamiltonian? And they give it in a very abstract form. So E naught A kit plus E naught plus delta B kit and B kit. Okay. And it is also given that A and B are orthogonal in nature and they are normalized vector. So A and B is 1, A and A is 1, A and B is 0, and B and B is 1. So it is also given. And second thing is given that they will just give you one operator, and that operator is P operator, and which will operate on A, that will change to B. And when this parity, and this is identified as parity operator, and this will operate on B, that will give you A. So they will just flip the state A to B and B to, and this is two state system, the state A and the state B. And E naught is, and E naught plus delta has dimension of energy. So this information is given, and P is the parity operator. So let's little bit work on what is parity operator. So parity operator will operate on any function. What it will do, it will just change the sign of position part. It will just change the sign of position part. Okay. Now there are two kind of parity. Either it is even one or it is odd one. So what will happen if psi minus x is equal to psi x? Then obviously, what is eigenvalue? So P
Yes,
One.
psi x is equal to psi x. That means this is even parity. This is even parity, and the eigenvalue is 1. And now, if P will operate on psi x, it will change to psi minus x, and if it will become minus psi x, then this is identified as what? Odd parity. So if we want to just change x to minus x, we have to apply the parity operator. And this will just give you the mirror image of position. You have x and now you have to go for the minus x. And this is what? Odd parity. So what is the eigenvalue for the odd parity?
-1.
-1.
Is -1. Now, so this is the background of the story. And we haven't started the question. Okay. So this is the background of a story. Now, what we have, the another, now you have the clear, hai na?
Yes, sir.
Okay. So now look at the, what is actually problem. The problem is very interesting. At t is equal to 0, we create the state with the eigenstate of Hamiltonian. At t is equal to 0, we have just created a state at the from the eigenstate of Hamiltonian, which will even parity at t is equal to 0. So first we have to calculate what will be the eigenvalue and the eigenstate of your Hamiltonian operator. So one psi state we have created with the eigenstate of Hamiltonian operator. So let us, hence you can see A and B are orthonormal vector. Then you can easily check. You can easily check H A vector is equal to E naught A and H B vector is equal to E naught plus delta B. Isn't it? So you can just operate A from here. So this will be 1, this will be 0, this will gone. E naught A will survive. You will operate B here, then this will gone, this will 1, and this will survive. So yes, we have two eigenstate, one is A and one other is B with eigenvalue E naught and E naught plus delta. And t is equal to 0, we can create one state. We can create one state which will actually even in nature. So we can write arbitrarily one state C1A plus C2B. And this psi state is even in nature. This psi state is even in nature. Now, what will happen to this parity? And parity with this particular operator have entirely different relationship that is given. So these all things are abstract. So what will happen? If we will operate p psi, hence it is even operator, that should be psi, isn't it? Hence it is even operator. So p psi is equal to psi. So what will happen when we will operate p psi onto this particular psi? So when we will operate p psi, then C1 PA plus C2 PB. P will operate on A. What you will get? C1 B. P will operate on B. What you will get? C2 A. And now, according to this particular definition, P psi must be equal to psi. That means C1 and C1 B ket plus C2 A ket must be equal to C1 A ket plus C2 B ket. What is meaning of that? From here, we can easily figure it out. What will be value of C1 and C2? So what is value of C1 and C2? If at t is equal to 0, this is your even parity. What is value of C1 and C2?
So 1 by root.
Then
1
C1
by root
is equal to C2. I can easily take 1 by root 2 e to the power I theta. Isn't it? You can take it complex number, but okay, take the real number, that is 1 by root 2. So now we can completely define our state at t is equal to 0. Because unless until you don't know what is your C1 and C2, you cannot define your state completely. So we have defined our state at t is equal to 0. Now, what is the next story? Look at this conceptual question in your exam. The next story is that after what time t, psi t will be have odd parity. We can give the guarantee that psi t will be in odd parity, or they have used very tough language. After what time t, such that psi t will have, we have 100% probability, and you have one probability such that it has odd parity. That means we have to evolve this psi with the time, isn't it? So how
Yes, sir.
this psi will evolve with the time? Your psi will evolve with the time, something like this. So let's go for postulates 5. So everybody is comfortable up to this?
Yes, sir.
Okay.
Yes, sir.
So what we have basically now I have psi at t is equal to 0, 1 by root 2 a ket plus b ket. This is my psi at t is equal to 0. And we have psi after time t according to my postulates. Hence, we have eigenvalue E0 for E and eigenvalue E0 plus delta for B. So that value is A e to the power minus I E0 t upon h cat plus B e to the power minus I E0 plus delta t upon h cat. Isn't it? We know all these particular postulates, so we can use this particular
sir.
thing. So now what will story, the final story is that we have 100% guarantee that after time t, this has odd parity. Means if we are operating psi t after time t, that will be something minus psi t, isn't it? This thing will be exactly equal
Yes,
to this one. Then we have 100% probability, isn't it? And we have to find that particular time when this kind of situation is take place. So yes, just operate P here. So what will happen? If we are operating P here, then this will be, I am just using this space also. What will happen? This will change into what? B
B.
e to the power minus I E0 t upon h cat plus this will change to A e to the power minus I E0 plus delta t upon h cat. I am writing this one. And now you have this particular thing with the minus sign. So minus 1 by root 2 a cat e to the power minus I E0 t upon h cat minus, and you can take 1 by root 2 common, or you can write it here, 1 by root 2 b cat e to the power minus I E0 plus delta t upon h cat. What I can do, I can take e to the power minus I E0 t h cat common, such that both will cancel out, and the relevance of half 1 by root 2 is also not there. So what we will get? We will get b plus a e to the power minus I delta t upon h cat must be equal to minus a and minus b e to the power minus I delta t upon h cat. And now this thing will be true when this thing is going to true, when you have this particular value is equal to -1, isn't it?
Yes, sir.
है ना? Then this value is, then both will be same. So what will happen? You will get the answer. You will get delta t upon h cut must be equal to pi, and where the t will be pi h cut upon delta. Wonderful. It's an awesome problem, and what I can say, this is the best question ever asked into the any examination of quantum mechanics. But yes, we can apply our concept. This type of question you cannot mug up, isn't it? But each and
Right,
everything
sir.
we know. We know what is the orthonormality. We know how my time is evolving, our state is evolving with the time. We know what will be the definition of parity. And if you know all the definition, you can do it step by step, and you will get the answer. And look at this particular level of your exam. So I request you, just go and do each and every step by yourself. Each and every step by yourself. Okay. So this time I will just try to do some session just like a problem solving session, such that you will also try to see which type of problem is coming into your exam, and we will also take some good questions time to time. Okay, at least we have 7 to 8 session, something like this, extra session. Okay, other than your classroom and whatever we are doing
Yes,
in
sir.
the class. Okay, so I think this is beneficial to you because you can see that how I am solving it. If you have any shortcut, I have not any objection, but that shortcut must have some conceptual rationality. ओके, ऐसा नहीं कभी भी क्वांटम मैकेनिक्स सर ऐसा होता है इसलिए यहां पर ऐसा होगा. ओके, डोंट डू दिस थिंग. Okay, so I think I will stop this class here, and